But in radio astronomy, in interferometry, you don't observe, you don't have images. So what the telescope observes is a voltage signal, so not very sexy. And what we do is a very long process to bring this voltage from something that is not an image to an image. And when you see that there is a detection of the source of the target that you were planning to observe, that is really exciting. So the first time you see an image after this calibration process is something that I really like to do.
Welcome to Chelonia Podcast, a podcast about the use of scientific discoveries and of technology applications. We provide the best information on projects participated by Chelonia and many more. My name is Gabriella Bernardi. I'm a science journalist, and in today's episode we talk about gravitational lensed supermassive black holes with Dr. Cristiana Spingola, postdoc fellow at the INAF Institute for Radioastronomy in Bologna, Italy. Nice to meet you. And would you please briefly introduce yourself?
So thanks, Gabriella, for inviting me. So I am Cristiana Spingola, and as you said, I'm postdoc at INAF Institute for Radioastronomy in Bologna. So I am a radio astronomer by background, and in particular, I am an observational astronomer. And I work in this institute in Bologna that operates the three main radio telescopes in Italy, so 3 out of 4, which are the Northern Cross, Medicina Radio Telescope, and the Noto in Sicily. And so actually a nice book has just came out about the radio telescopes and the history of the institute. So it's called Why Don't You Build a Radio Telescope? And so yeah, I grew up in Perugia, so I come from the very center of Italy, and then I moved around, passing from Bologna, then moving to the Netherlands, and then coming back to Italy in 2019.
How did you first become interested in astronomy, and what or who inspired you?
So I think many people says since I was a kid, I was looking at the sky. So that wasn't my case, but I was always interested in nature. So when I was little, actually, I changed my mind many times. I wanted to study plants, and trees and leaves. But then in high school, I followed this course on Greek literature. And this course was led by an astrophysicist. And so he was telling about astronomy in Greek literature. And that's when I fell in love with astronomy and its interconnection with many other fields. And so I think that, that was this teacher who really motivated me. And it's really amazing how a single teacher can change your decisions.
Why is so important the study of radioastronomy?
So first, I would like to say that there is no wavelength more important than another, because if we want to understand the universe, we really need to collaborate and so to use all of the wavelengths. So radioastronomy is important because it's complementary to the rest of the wavelengths. And compared to the optical astronomy, where we see the hot universe, in radioastronomy we see the cold universe. So, for example, with radioastronomy, we identified the emission lines in stars' birth sites, but also we detected for the first time the ripples in the cosmic microwave background, and so the so-called CMB, so generated in the very early universe, right after the Big Bang. And we also observed supernovae, which are these stars explosions, and they're super beautiful at the radio wavelengths. So if we were to look at the sky with the radio eyes, so our eyes unfortunately are insensitive to the radio wavelengths, we would see a completely different sky. So we would see extended galaxies and supernovae explosions, but also we would see what is called the quasar, so quasi-stellar radio objects, which are supermassive black holes that are active, and they are seen mostly at the radio wavelengths. And super important because they can be seen up to the highest redshifts, and so they can probe the evolution of supermassive black holes across the cosmic time.
Can you tell us about your latest paper where you zoom into very faint black holes?
And that was a very exciting discovery. So we observed these supermassive black holes by using different techniques. So I will try to explain the method. So first we observed this at the radio wavelengths using antennas that are connected throughout the globe. So it's called interferometer. And so by connected antennas so far away from each other, it's like having a supergiant telescope that gives the sharpest view of the most distant universe. And so we discovered this peculiar system with many images of the same background source. So this effect is called the gravitational lensing. So we use also galaxies as natural telescope to magnify the distant universe. So what happens is that when we have a massive object between us and a very distant source, if there is an alignment between us, this object that we call the lens, and the background source, as an effect of general relativity, the light is bent around the massive object. And so what we see is multiple images of the same background source that are an enlarged and magnified view of this system. And so without this galaxy that happened to be in the middle, in the way, we wouldn't observe this distant source, which would be too faint to be detected. And so this source is peculiar because it seems that there are actually two supermassive black holes. So we observed this also at X-rays using the NASA Chandra Observatory. And this work was led by Dan Schwarz, who is a senior physicist at Harvard and Smithsonian in Boston. And so we observed this with Chandra, and we found also at X-rays that there are two X-ray sources. And so it's a pair of supermassive black holes that are orbiting around each other. And this is important because first, they are super faint. So without the lensing effect, we wouldn't be able to observe it. And second, because these systems probe the evolution of supermassive black holes. So observing them and characterizing them is really important to understand how supermassive black holes evolve to what we see now, like in the local universe.
Fantastic, congratulations.
Thank you.
What excites you most about your job?
So I think learning every day something new is thrilling. So that every day you don't know exactly what you expect, and also the new discoveries are always exciting. But of course, you don't have a new discovery every day. So I think it's a bit nerd what excites me about my job. But in radio astronomy, in interferometry, you don't observe, you don't have images. So what the telescope observes is a voltage signal, so not very sexy. And what we do is a very long process to bring this voltage from something that is not an image to an image. And when you see that there is a detection of the source of the target that you were planning to observe, that is really exciting. So the first time you see an image after this calibration process is something that I really like to do.
About learning, which skill learned as an undergraduate student served you best during your career?
Yeah, that's a difficult one because to do research you need many skills, but the most important, I think, they're the soft skills. So for sure the organizational skill. So during the university you have to organize your study and prepare the exams, and so you have to come up with a plan. And this is really important in research because you don't do one project at a time, but you end up doing many projects at the same time. And so organization for sure is one of the best skills that you can have. but also collaboration. So being able to work in a team is really important, because you never work alone. And so it's always a teamwork. Even during this pandemic, we use platforms to work with each other, but you are never alone in your discoveries.
Good. Do you think that the public perspective of women in science has changed over the course of your career?
So my career maybe has been too short to see a significant change. So, but I think that there has been some improvement. So at the beginning of my PhD, that was in 2014, talking about gender parity wasn't really a topic, or at least we talked about it among women, but it was very difficult to talk about this with men. Now, instead, it's easier to talk about gender parity and diversity in general with men. And actually, there are sessions in conferences that are dedicated to this topic and sometimes are led by men, which is a very good progress towards the gender equality in astronomy. I think it's still a long road, and this problem has a complexity that is quite high, but there is improvement and there is hope.
Perfect. If you weren't in your whole profession, what other career would you pursue?
So I think as an astronomer, but also as a human, I really feel the responsibility for the climate crisis that we are observing every day. So now in Bologna, there are kind of 15, 20 degrees outside and the plants are blooming, which is absolutely not what should happen in this period of the year. And so if I weren't doing astronomy, I would for sure work in renewable energies or sustainability. And so I actually had a small period of time working in the research in renewable energies, in particular in solar energy, because of my astronomical background. And I really feel that is the way that the society should go, like using what we already have to produce energy. But the road is long also in this direction, so we do not know so much about it, how to use it, and so I would like, if I weren't doing astronomy, for sure I would like to contribute to that field. In the meantime, I became part of a group that is becoming larger and larger, that is Astronomers for Planet Earth, and it's a very active group where they also have courses and they provide materials about the climate crisis. And so I strongly recommend it to check it out, because it's super interesting and useful, I think.
We are at the end of this podcast, but if you could go back or forward in the time, what would you like to discover, or who would you like to meet?
That's a super interesting question, actually. Yeah, that's difficult to choose a person, but for sure I would like go back to the past and meet Giordano Bruno. So he was kind of my high school idol, and I would like to tell him that he was right, and that 400 years later, astronomers observe quite frequently distant suns with planets orbiting around them. And so he postulated this, he died for this, but I hope that somehow he knows that he was right.
Thank you so much, Dr. Spingola, for joining us today at the podcast, and thank you to our listeners. If you have any questions about today's show, you can get in touch on Chelonia Twitter, and feel free to subscribe chelonia.swiss website and be part of the community. In the meantime, stay tuned for our next interview. Bye-bye.
Bye, thank you.